ready for the class? Are we ready for the class?
Yes, ma, we are ready.
Yes, we are, ma.
Okay, 18 participants. We have not reached, have we formed a quorum?
Not yet, ma.
Good morning, man.
So what is happening?
They are still logging in. They will soon.
They'll gradually
Okay.
join.
Let me share my screen now.
Morning, madam.
Picture me. So everybody mute yourself. Mute everybody. Please, let's not repeat what happened yesterday. Mute everybody. The admin, please mute everybody. Except when I say, when I want to know whether you are following, then somebody can answer. Is that okay?
Everybody is on, ma. Everybody is mute apart from you, ma.
Okay, thank you. So yesterday we talked about research, the origin of research, the roles of research. Talked about the ethics of research, talked about the politics before we entered into problem formulation, conceptualization, and operationalization. And that was where we ended yesterday. I don't know whether there's any problem yet. Is there any question from yesterday's class? Hello? Are we together?
Yeah. There's no question.
Okay. All right, thank you. So today we are going to look at measurements. Yesterday we were talking about trying to measure your variables, how to, even if it's not something that can be quantified, trying to get a way to quantify it, or even if it's a qualitative data, you should get a way of assigning values for easy analysis, because the analytical tools we have cannot analyze qualitative data. So because they are qualitative in nature, you cannot really go and weigh them or measure them. But there can be attributes that you can attach to them, or there can be indicators that will tell you that this is how to quantify them, so that you can analyze them and make inferences and draw your conclusion. So today we will look at how these measurements, the levels of these measurements, so that we'll be able to know when we encounter one, we know how to classify them and what is the level we can go with them. Okay, so today we look at measurements, and there are 4 levels of measurement in statistics. So the first one is nominal level. So here, I hope you can see my screen.
Yes, ma.
Yes, we can.
So, the nominal level The nominal scale or nominal level are just used for labeling. They don't have any quantitative value. Nominal scales. Oh, sorry. Wait, I'm coming. Sorry. The one that is showing. So nominal scale is just used as a level. Another way to remember nominal scale, nominal level is when you say, another good way to remember is nominal sounds like name. Just attach a name to something, and then that is the measurement. It doesn't have any that you give it one, assign 1 or 2 or 3 to it, doesn't matter. It doesn't mean that is the weight of that variable. It's just to give it a name. Example we have is sex. When you are talking about sex, you have male and female. If we want to analyze it now, you go to the field, collected data, and then when you are back, you want to put it in your what is it called, spreadsheet, and then you want to code it. Normally code this kind of values that are not quantifiable. So if you want to code it now as sex, male and female, if you say male, female is 0, it doesn't mean that female is more important than male, or male is more important than female. You're just trying to name it. You're just trying to give it something, to attach a value to it. So in other words, male can be 1, male can be 0, male can be 3, male can be 4, any number at all. It doesn't matter. It doesn't show that male is senior to female. Or you can say female 2, male, female 2, female 3, female 1, female 0. It doesn't mean that female is inferior. I'll give you another example. When you are talking about marital status, somebody is married, you can give the person 0. And I hope you are getting it. You can give the person 0. It doesn't mean that the married people are more important than the unmarried people. You understand? In the layman understanding, unless you are doing a work on marital stuff or marital status as a topic that you really want to get into the in-depth. But when you are just measuring marital status, a married can be 2, married can be 1, married can be 0, single can be 3. You understand? It doesn't follow any order. There's no order. There's no seniority. I don't know whether you are getting me.
Yes, we are.
Fanyam.
Yes, we are getting you, ma.
Okay, so in that case, it's just a name, it's just a label. Just see this nominal value as a label. So in that case, if you have sex now and you want to code it for your analysis in your spreadsheet, you shouldn't insist that a male should be 2 or female as senior, they should be 1. So even if you can code it any way, any side. No side is period. There is no order. You understand? So that is nominal level, and that is the least level you can see in measurement. That's the least level. Okay. Is there any question yet? I don't know whether somebody was talking. Gainkan. So okay, I assume that there is no problem. Hello. Okay.
We are
Abu?
with you, ma.
Okay.
We are following it.
Yes. Okay. So the next level is, I told you there are 4 levels. So the next one is ordinal scale. Ordinal scale. So with ordinal scale, the order of the value is important and significant. You see now we have introduced an order. There is an order. There is like a level from one level to another, so that you don't just come and give 3 to something that is supposed to be under, that's supposed to be lower. So you give you assign values based on the from the highest order to the lowest order. So, but the problem here is that the difference between each one, that's from one level, from one order to another, is not known. The difference is not known, but there is an order now. It's not just like a nominal when there is no order, you just assign anything to anyone. But this one, there is an order. But the problem is we don't know the difference from one level of the order to the other is not known. So I'm going to give you an example. Ordinal is easy to remember because it sounds like order. Ordinal scales are typically measures of non-numeric concepts like satisfaction, happiness, discomfort, and etc. So, example, when you have educational level, although recently, when we want to measure educational level, we normally measure it in the number of years spent in school. But before now, you can still measure it this way, in this level, where you have none, that's somebody that has no formal education. The second level is primary level. The next one is secondary level, tertiary, and postgraduate. So the none has the least number. So if you want to code it or to give it assign numbers to it, the none can be 1 or 0, as the case may be. Then primary can be 1. Normally I give none 0, primary 1, secondary 2, tertiary 3, postgraduate 4. So that you can see now that there is a level, there is an order, and is in that form. But the problem is that we don't know what is the difference between no education, as in none, and primary. There is no sharp difference that you can say this is the difference between this and that. Again, when you look at something like organogram, that's from if we come to IPES now, you can see from center leader to deputy director to this one, deputy center leader, environment, social standard, and whatever, procurement. From there, it comes down, they have an organogram. So that is the level, that is ordinal scale. So if we want to assign values to whatever they are doing, you know that it starts from the top, the director or the center leader has the highest value that you can think about. Then it comes down to the lowest person, maybe to the students in IPES. So that is ordinal scale. Is there any problem? Is there any question?
There's no problem, ma.
Okay, so that is the second level of measurement. Now we have introduced order, but the difference between the order is not known. So we'll go to the next one. The next one is the interval scale. Interval and numeric scales. You can see now numeric is entering. Numeric is something that you can count, or you can, yes. So numeric scale, in which we know both the order There is the order, there is order now, and the exact difference we know too. The exact difference between the values. So interval itself means space in between. So the important thing there is that we remember that it does not tell us only the order, but also the value between each item. So a classical example of an interval scale is Celsius temperature, because the difference between each value is the same. Hello, Bala,
Yes, ma'am.
okay, please mute. If you have, or you have a question?
No.
Okay. Okay, so the
No,
example
ma,
we
no
normally.
question, ma.
Hello? Sure, Kura.
No
Yes, Teve. Raf.
question, ma. No question.
Okay, I hope you can hear me.
Yes, ma. No question.
Okay, okay,
I can hear you clearly, ma.
okay. Thank you. So the example we normally use for interval scale is the Celsius temperature, because the difference between each value is the same. That's, we now know that there's a difference between each, and we know the value. In this case, in Celsius temperature, the difference between one to the other is the same. So, for example, let's see, the difference between 60 and 50 degrees is a measurable 10 degrees, as is the difference between 80 and 70 degrees. So the problem with interval scale is that they don't have a true zero. That is what differentiates it from the next one we're going to see. It has all these features. It has an order. It knows the exact difference between one order and the other, the second order. It knows the space, the difference in the space in between. But the problem is that it doesn't have a true zero. Let's see what it means by true zero. For example, there is no such thing as no temperature. When you have 0 degrees, when you have 0 degrees Celsius, do you say there is no temperature? When you have 0 degrees, a thermometer is reading 0 degrees, 0 degrees. You don't say there is no temperature, because that one is 2. That 0 degrees is another temperature of its own. It's not like the 0 that we know, that when you hear 0, you know that it's nothing, right? When you hear 0 in ordinary mathematics, you know that there is nothing there. But here in Celsius, when you hear 0 degrees Celsius, it doesn't mean there is no temperature. There is still temperature. So that is the problem that interval scale has. In the case of interval scale, 0 doesn't mean the absence of value, like we know in ratio and other things. It doesn't mean the absence of value, but it's actually another number used on the scale, like 0 degrees Celsius. So negative numbers also have meanings in Celsius. Without a true zero, is impossible to compute ratios. If hello, Igila, mute yourself. You are just coming in. If you are coming in, just mute before you enter. Okay, so the problem with this is that it doesn't have a true zero. We have said it. And when you don't have a true zero, it will not be possible for you to compute ratio. I don't know whether we know what ratio is all about. This over this is equal to this and this, as in 6 over 6/3 or 6 into ratio 3 or so, it gives you what? What is the ratio of 6 and 3? So because there's no true zero, it's not possible for you to know the ratio or for you to compute ratio. That means with interval scale you can add, you can subtract, but you cannot multiply and you cannot divide. So let's consider and see what happens here. Consider this 10 degrees Celsius plus 10 degrees Celsius. When you add 10 degrees, 10 plus 10 we know is 20. So what we are saying is that 20 degrees Celsius is not twice, it will not be as twice as hot as 10 degrees. That's the ratio we are saying. If it has a ratio, 10 degrees is very hot, 20 degrees should be like 2 times the hotness of 10. That's when you have ratio, that's the ratio we're talking about. 20 divided by 10, that's like 2 times of the hotness. But in this case, because there is no ratio, because there is no true zero, 20 degrees Celsius will not be as hot as 10, will not be as twice as hot as 10. So, however, there is no such thing as no temperature when it comes to ratios, to Celsius scale. When converted to Fahrenheit, it is clear that 10 degrees Celsius is equal to 50 Fahrenheit. But 20 degrees Celsius, if it was like ratio, it's supposed to be, is it not 10 times 2 that gives you 20? So it's supposed to be 50 Fahrenheit times 2 to give you 100. But it's not so. 20 degrees Celsius is only 68 Fahrenheit, which is clearly not twice as hot as the other one. So as hot as 10. So I don't know whether this is clear. They normally give example, even in all textbooks, with in this interval scale. Again, another example, apart from this Celsius degrees and Fahrenheit that we have been using, another one we can use is ranking of school students, where you rank them first, second, third, fourth, like that. Why is it so? Here we have a rank, we have an order. The first person must have scored highest, right? The second person is the one following the first. But here now we can now have a difference between what the first person scored and what the second person scored. So we can now know that there is a difference in what this person has scored and what the second person has scored. So we can know the difference, which is the typical of interval scale. The spacing between can be determined and there is an order. Yet there is no true zero for us to compute ratios. That is the only thing that this feature does not have, a true zero. Is there any problem? Is that clear? Some care.
Yes, it's clear, man.
Okay. All right. So, and another thing I need to state, although I didn't write it, maybe before I post I give you the note, I have to tell you the level you can use for the analysis of each of them, because it's not what the level you can go with interval scale that you can go with nominal scale. So as the thing is getting higher, that is how complicated the analysis can be. The other one, the first one, which is nominal, you can only use frequency and percentage. That's the highest you can use for that. Frequency and percentage. I don't think you can go more than that. So, but the other, the next one, you can do a little of other, the ordinal scale. You can progress till you get to the interval scale that we are going at, the ratio scale that we will soon look at. So be mindful that it's not all of them that you cannot come and use when you have a nominal scale value. You can't use it to run regression. I hope that's clear. You can't come and use the nominal regression, nominal scale to come and run regression. But you can use it to do percentages, frequencies, modes, chi-square, and other things. So for ordinal scale, the statistics you can use for median, you can use for non-parametric ANOVA, rank order correlation. Sorry, I didn't put it in your note, but I will put it in your note. Who are those disturbing the class? So for interval scale, you can use mean, mode, median, range, standard deviation. You can do standard deviation for interval scale. You can do. Why is the class rowdy like this? What's happening? Is there any problem? So I just listed it, but in your note, before I give you, I will fill in for you so that you know the level you can go in your analysis. It's not when you have a nominal values. You guys say I want to use regression.
These people are just coming in and disturbing the class.
Right. Please, can you mute yourself? As you are coming in, you mute yourself. Please, the lecture is already in progress. So, for interval scale, you can use the Pearson moment correlation, factor analysis, ANOVA, t-test. T-test. You can use t-test in your analysis for interval scale. So we are going to the last level of measurement, which is the ratio. The ratio are the ultimate when it comes to data management measurement skills, because it tells us the order, it tells us the exact value in between, and most importantly, it has an absolute zero. When you see zero, you know that there is no value. That is what it means here. When you see zero in this level of measurement, you know that there is no value. It's all like in interval scale, you don't have a true zero. If you have a zero there, it still means a value. It still represents something. So here we have a true zero. And for this, we can construct ratios. It allows us to do a wide range of descriptive and inferential statistics. So everything above about interval data applies to ratio scales, plus ratio scales has a clear definition of zero. So example of ratio variables are when you talk of your height. when somebody has 0 height, that means the person doesn't have any height. That's the multiplication. Or when you have 0 income, let me use income.
No, not me. And
all these people that are talking, I will leave this class for you. You will be the one to lecture it. Jigba. So we're saying that examples of ratio variables are when you are looking at people's height, people's weight. You know that somebody's weight can be 80, 70, 75, this one 20, like that. And then when the weight is 0, that means there's no weight. The person doesn't have any weight. They're like a feather. Duration, age, your age, your income. Somebody has 0 income. That means there's nothing in the person's hand. He doesn't even have 10 naira. That's the meaning. So examples are so many weights, number of employees in a company, speed in miles per kilometer per hour, length in centimeters, age, income, sales, you have made sales and all that. So all these are ratio variables, ratio level of measurement. And that is the highest level that you can think about. So here, you can use any analytical tool can go here. So is it not wise for you that if you are getting your variables, if it's possible to get them in ratio form,